Hey everyone, Dr. Walker here. This is video 226. It is called Simplifying a Capacitor Circuit. We're going to be learning how to find the equivalent capacitance of a circuit when you have a combination of capacitors. So this video is going to be accompanied by another video with a guided example, and that's where you're really going to learn how to do this. But basically the idea to simplify a capacitor circuit is that you're going to do a step-by-step application of the series and parallel rules. So if there are two capacitors in parallel, you simplify those, and then you see what you have left, and then you keep simplifying what you can one step at a time until you are left with one equivalent capacitance. So in this video, we're going to do one example. It's not going to have numbers, it's just to give you an idea of how this works. And then in the guided examples, we'll have numbers and we'll have a more complicated circuit. This question asks, which of the following combinations of identical capacitors has the highest capacitance? So you can definitely try it yourself, try to apply the equations for series and parallel capacitors and simplify each circuit and see which one has the highest capacitance. You do have to assume for this problem that all of the capacitors are identical. If you want, you can just pretend they all have a capacitance of 1 farad just to simplify things. So give it a try and then take a look and let's see how to do it. So circuit A is just 1 farad. That's the equivalent capacitance. In B, are they in series or parallel? They are in parallel. You have the two capacitors connected. These two plates are connected with that junction in between, and the other two plates are connected with this junction in between and nothing else in between. When capacitors are in parallel, do you remember the equation to find the equivalent capacitance? The equation was the equivalent capacitance equals the sum of all of the capacitances. So we'll call this C1 and C2, but they're all the same anyway. You just add them up and we're going to get 2 farads. And again, we usually use microfarads, but just to simplify numbers, that's why I'm using 1 farad. What about the next one? How are these connected? Did you say series? If so, you're correct. They are in series, they are directly connected with just 1 wire, nothing else in between. What's the equation for capacitors in series? Do you even need the equation? Do you remember the shortcut that I taught you in the previous video, right? The shortcut said, if the capacitors are identical, if there's only 2, then the equivalent capacitance is half of the value. So without even using the equation, we know the equivalent capacitance is 1/2. Now, if you do want to use the equation, we can go ahead and use it. It's the 1/, equation. So 1/, C1, which is 1, and then 1/, C2, which is also 1. So 1/1 plus 1/1 is 2. And then to get C equivalent by itself, remember we have to take the reciprocal, so we do get 1/2. The last one is the more complicated one because it has 3 capacitors. Initially you might think, oh, it's got 3 capacitors, it's got to have the highest capacitance. But let's take a look and see what the capacitance is. So the first step is to identify what's in series or parallel. And the only thing we can identify, because we've dealt with this circuit before, is that these two are in parallel. So what we do is we simplify these two first. What we're going to do, and I'm going to do it down here, is we're going to redraw the circuit. And I'll actually do it over here just to make sure I have plenty of room. We're going to redraw the circuit. And instead of drawing 2 capacitors, since they were in parallel, we're simplifying them to their equivalent capacitance. Let's call this one C1, and then C2 to the left and C3 to the right. When I simplify capacitors, I like to give a name to the equivalent capacitance But if I always call it C equivalent, it might be hard to figure out what's what. So we got C1 over here, and I'll call this one C23, simply because it is the combination of capacitors 2 and 3. And then what I'm going to do is I'm going to calculate, well, what is C23? The two capacitors were in parallel to get to C23. When they're in parallel, you just add the capacitances. So C23 is going to be 2 farads, because we're just going to add C2 plus C3. See how this works? And then, now that we have C1 and C23, and we only have 2 capacitors left, we can see, okay, now they're in series. Now that we have simplified 2 down to 1, now there's only one single wire connecting them. We can simplify again to one equivalent capacitance. So this is the final equivalent capacitance. You can call it C equivalent. You can call it C123, whatever you prefer to call it. And those 2 capacitors were in series. So to find this C equivalent, we're going to use the 1 over equation. And the capacitors are C1, so 1 over C1, and C23. So 1 over C23. That's how you use the equation. You just plug in whichever capacitors are in series. So it's going to be 1 over 1 plus 1 over 2. So that's 1.5. 1.5 is also 3/2. And I'm just writing it as a fraction. That way it's easier to take the reciprocal to get C equivalent by itself. Just flip both of them and we get 2/3. So you can see that this combination has less capacitance than a couple of the other combinations. So the final answer, which one has the highest capacitance, is the combination B with the 2 capacitors in parallel. So if you enjoy this kind of drawing circuits and simplifying capacitors and doing these calculations and simplifying until you get to that final result, final capacitance, then you're really going to enjoy the guided example where we're going to do slightly more complicated problem with a few more capacitors. I will see you in that video.